Hello and welcome to another video where we will be making a 3D model from a 2D print. This time it's not a tutorial to be practice model, it's a model that came up as a question from a fellow user in the forums. And I think it's an excellent model to showcase a 3D sketch, right? Because it's an exhaust manifold with two pipes only. But first, I've got a Ferrari here with me and let me drink some coffee from it. That's the only Ferrari I have. But without further ado, let's take a look at that print. So let me explain to you how this works. I've got this going straight up for 34 millimeters, right? Then you start and you do an arc of 20 millimeters. And then you go straight again at an angle of 35 degrees to the original straight line. Let's pretend this is a straight line, right? So at an angle of 35 degrees until you are 20 millimeters away from that center line. Okay, this is a center line, so the part is symmetric, right? So that's how you do that. Now, as you go up here, right, you also curve to create a radius of 20 degrees, and then you've got a little straight piece until you reach 36 millimeters from the original line that you started with, from the original plane. Let's hop in, start designing. This is an exhaust manifold. Okay, now we're going to start a 3D sketch. Now, couple of rules, right? First of all, you will have the grid on, right? You always need the grid on, and why is that? Because when you are cycling the sketch planes, you can tell at which sketch plane you're on very, very easily if you have the grid on, okay? And now the second thing is you need to click here and have this elevation measurement showing, right? This is a measurement. It can also define the elevation. I will do a more advanced 3D sketch video down the line, but for now we will be using this only as a sensor to know at what elevation we are from the selected sketch plane. Okay, so now I want to sketch in the YZ plane. So yep, I'm there. Let me start. I'll draw a line here. Now you see that at some point it snaps and it's showing an arrow and a padlock. That means I'm vertical basically, right? This direction is locked. And you also saw that I didn't start at the origin. Well, you cannot snap to the origin in 3D sketching, right? You can't snap there. What you can do is you can use the coincident constraint, click it from the Design Explorer, and you're done. So let's dimension this at 34 millimeters. Then we'll start a tangent arc, and that tangent arc is going to have a radius of 20 millimeters, and we need it to go on for 35 degrees. So how do we do that? Well, draw a couple of reference lines. By the way, you'll see that I'm in a 3D sketch, but I'm just 2D sketching for the moment. Okay, and then I'll tell this that, you know what, this is going to be 35 degrees. Okay. Then I'll draw another line. Come on. Okay, I'll draw another line. I will make this line tangent to my arc. And this needs to go on until we're 20 millimeters away, right, from here. Well, how do you do that? In 3D sketching, when you click point to point, you can only dimension between these 2 points. Right? You can't dimension it. It's not going to change and snap to the vertical or horizontal dimension. So how do you do that? Well, you go old school and you do a couple of reference lines. Make sure they have the arrow and padlock. Then you make the ends coincident, and then you can dimension this to be 20 millimeters, and you're done, right? So this is exactly where it needs to be. Now you will see that it's still red. In 3D sketching, right? It's a red sketch. In 3D sketching, you don't get to be fully defined, right? You can drag and see if anything moves or is underdefined, but it's basically, it works like that. Okay. So now I want to switch my sketch plane, right? Now I want to make a line that is parallel to the ZX plane. Okay. My elevation is 0, and if I start a line, now take a look at this. If I hover over this point, elevation says 0. If I hover over this point though, the elevation snaps to 20. While I get this point icon on my screen and the elevation 20 sensor showing, I'll click, and then I want to draw the line in the direction I want. I want to have a arrow and padlock. There you go. Look at that. Okay, so how much is that? Well, according to the print, it's 36 millimeters. Is it though? Yep, there you go, 36 millimeters. So we're good to go there. Let's get back to our drawing. And okay, but I want this, as it goes up, I want this to create a 20 millimeter radius arc. So there you go, radius 20. I hit OK, and we're done. Okay, so this is the profile of our pipe. Now, I will select the XY plane and draw a circle of 15 millimeters. Now 15 millimeters is, let's go back, 15 millimeters is the outer diameter, and we've got it showing here. It's the outer diameter of our pipe. Basically, the inner one is 11. Okay. And I will finish this, sweep it, and it's already selected, my circle, and as a path object, I will select this, and there you go. That's one of our pipes. Now, I could have made a thin sweep, right? And I had the pipe shape going from the start. I don't want to do that because then when I mirror it, which I will do right now, I will mirror, select this feature, and select the ZX plane. Okay, now here I would have had surfaces intersecting. It would be a mess. I would have to select them somehow, remove face. It would be a mess. Whereas now, what I can do is go into the shell command, and I want to say that I want to create a shell with these 3 faces removed, right? And I want to end up with an inner diameter of 11 millimeters. My external is 15, so my thickness should be 2. So 2 millimeters either side makes 4 millimeters. And that will give me an internal diameter of 11. Okay, so what do we do next? Well, next, I want to be creating this flange here, right? That's going to be bolting onto the cylinder head. Now, we're not shown the thickness of this flange, right? So we don't have this thickness here. But what we do have is these 66 millimeters from point center hole to point center hole. Now, you will see that this is a slot shape flange. So we will assume that you go straight here, you start an arc, and that arc passes through the center of that bolt hole, right? Then goes back, and that will give us a fully defined slot shape for this flange. Okay. So we're going to start a 2D sketch on this surface. I want to project these 2 shapes in as geometry because I want them to be holes. Okay. And then, oh, by the way, I don't like the grid in 2D sketching. If you like it, you can leave it on. I only use it in 3D sketching. So arbitrary rectangle here, and then what you do, you select this point to be a midpoint of this line. Then you select this point to be coincident to that line. Okay. And then you need to make these two reference lines. We will, oh, sorry. So we'll make a couple of arcs there, center arcs. Now we have our slot shape, and we want it to be 66 millimeters from edge to edge. So as soon as I select the two arcs to dimension, I get a menu here, slot dimension options. So how do I want to dimension my slot? Well, from outer edge to outer edge is option number 0. So that's what I want to do, and that's 66 millimeters. And I will extrude that, right? I will extrude that for 6 millimeters. I want to go back towards, right, towards my pipes, because the 36 millimeters, let's see the drawing, because the 36 millimeters that I selected here in my 3D sketch as the path for the pipe, that ends at the end of that pipe, right? Let's get back to our 3D. You'll notice I didn't do the little ears there. I'm going to do them in a second feature, because I would have needed to do a lot of trimming and reconstraining. There's no need to do that, right? Whereas now I've got these slots, I have this slot, I've got these arcs, I can just say that it's at the center of the arc, right? And I will also do these holes, and I'll show you a little trick. Okay, so where are the dimensions there? Let's go back to our print. And where are they? So R5, so for the other one is a diameter 10, and the inner one is a diameter of 4.5. So let's go do that. You would have noticed that I made them equal earlier, so I just need to dimension one set of them. There you go. That's four. No. Inner one. Okay, that's 4.5. Okay. I will extrude to geometry here in the back. Now, I mean, that's not a bolt hole, is it? No, it's definitely not a bolt hole. But in Alibre Design Pro and Expert, we've got direct editing tools, which, by the way, are parametric, right? They do recognize which features you messed with, basically, and they adapt. So I want to remove this face, right? And it knows that if I want to remove that face, I probably want to continue and complete that circle, right? So I'll do the same here. And I hit apply. And now that is parametric, right? Because if I edit that sketch now, if I say that this is 12 millimeters, this is somehow 3, right? Okay, I go back and you will see that it is parametric, right? So you don't be afraid to use it. It's a great tool. It allows you to do, complex geometry relatively easily. And yeah, sometimes you can only get something done that way. Of course, I could have done it multiple ways here. I just wanted to show you that. And finally, I've got some fillets here. This and this, and they're 5 millimeter fillets, and we're done with the flange as well. And now we need to do the other little flange down here. So let's go check our drawing again. So we need to thicken the bottom to 20 millimeters from 15. Okay, that goes up for 4 millimeters. And then we thicken it even more. We create a second flange that's 25 millimeters, and that goes up for another 6 millimeters. Okay, and at this point, it's probably useful to mention that you see that we've got the chamfers. marked as C1, C2, and C3, but we don't have a table showing us what these are. So I will eyeball them. So let me start a sketch here. I want to look at it the other way. I want to project this in, and then I'll go up 6 millimeters. Okay. I want to go outwards up to 25 and then up to 20. Now I want to dimension these. I want a diameter of 20 there, so that's a radius of 10. That's a height of 4, and that is a diameter of 25 divided by 2 is 12 and a half, or you can just type in the equation. Hit OK. Oh, by the way, while you're still in the sketch, right, what I could have done is hit space to bring up the context menu bar, which I call the Harold bar, because Harold showed me, told me about this trick that you can just hit the space bar and not hunt around clicking on the background, right? So I'm hitting the space bar and I'm selecting revolve. And it's selected the sketch that I was working on, and it just needs an axis, so I'll do that. And then now we need to make a chamfer there, which I need to eyeball. And I mean, it's a big one. So yeah, that's 9. That's 9 millimeters, not 6. Okay, we can. Alibre is parametric. We can fix that. I will say, let me zoom in. Okay. So I will say that that doesn't go, exactly the same as this line. So it's not at 20 millimeters. I'll say that it's 1 millimeter off, right? So I will plug in a chamfer of 1.5 millimeters here and see what happens. Okay. So let's go back to our drawing. I want to double click on a face, which will open up the sketch that created it, right? And that 6 is a 9. Looks more like it. Let's give it that chamfer now. Let's see, I said 1.5 millimeters. How does that look? 2 millimeters maybe. Yeah, 2 millimeters looks better. Okay, then the print says that on this edge and on this edge, you have a chamfer that's the same size. Okay, and if we check the print, I would say that this is a 0.5 millimeter, right? That looks good for me. So let's go back here. So I'll just go. So I will select this and come on this, and I will say 0.5 millimeter. Does that look good? Yeah, sure. That seems, oh, other side too, yeah, right. So we got that one going as well. Let's check the print. Have we got anything else to do? C3, yeah, I've got this little chamfer down here. Let's see. That's a big one. So I'm going to say 2.5. No, even more. 3. Yeah, that looks about right. So let me turn off my drawings, turn off my planes, and there's our part, guys. If I turn these off and on, they refresh so that the floor is showing, down here. Look at that. That's a cool looking part. Oh, we forgot a very, very important feature. We forgot the fillet here. Right, that is supposed to be a 7mm fillet. You just need to remember to make this fillet after the shell, because that way, let's slice it along the YZ plane, because that way, this, this is what this fillet is basically a weld seam, right? And if you do it after the shelling, what you'll get is two clean pipes, right? Two constant diameter pipes. That's what we want. So we need to put in the fillet after we shell. And that's it. Cool looking little port. And made with, well, the main component done with a 3D sketch for a path, which I think was really cool. So if you want more videos like this, click on the end card, watch another video from my channel, or subscribe if you want to be notified about my new videos. If you liked it, hit like. If you didn't like it, hit dislike. I still want to know if you didn't like it. And I do hope I see you in the next one. Cheers, guys.